Right, in this question we've got to prove that n cubed plus 2 is not divisible by 8, so any cube number with 2 added on. And then we've got this bit at the end here, which hopefully you'll be familiar with. What that means is n, that thing there just means belongs to, and then that double scripted z there is the symbol for the integers. So this bit at the end is just a maths way of being able to say that our number n has got to be a whole number, so we haven't got to worry about messing around with decimals or anything of that kind. So we can't do any algebraic manipulations with this. There's nothing really we can do factorising wise or anything else with n cubed plus 2. So what we're going to do is go at it in a kind of way by exhaustion. Now, proof by exhaustion would mean you'd normally start off with going, okay, let's have a look at what that is. That's 3. Is it divisible by 8? No, it's not. So then we've got 2 cubed plus 2, which is 10, divisible by 8. No, it's not, and so on and so forth. But that's really long-winded and ultimately not possible, because you'd have to do this with every single number. And of course, there's an infinite number of those, so you'd be there forever. So this is just not going to work. So let's just get rid of all that and have another go. And what we're going to do is start off by saying, okay, well, let's have a look at what we can do with the even numbers. And let's see if we can do some kind of proof with regard to even numbers, and then we'll have a look at the odd numbers. So our even numbers can be written in the form, let's say if n is going to be even, we can write it as being 2m. So that's now an even number. So what we've got now is our n, which we said is in that form, our even number cubed plus 2, which is now, if we do some cubing, we've got 8m cubed plus 2. And what we see clearly is this bit here, that bit is a multiple of 8. And then if we add 2 onto it, clearly that is no longer going to be a multiple of 8. So therefore we've proved that our even numbers are not a multiple of 8, so that's that bit done. Let's have a look at what's happening with our odd numbers now. Because if we prove it for the even numbers and then we do something similar for the odd numbers, then we've proved it for all our numbers. So there we're going to say, okay, let's make n an odd number by saying, okay, let's call it 2m plus 1. So what's going to happen here? Well, we've got to do the same thing again, but this one's a little bit more complex. So we've got 2m plus 1, and we've got to cube it, and then add the 2. So what we've got to do, we've got to do some multiplying out those brackets. Now you can either string 3 brackets together and multiply them all out, or if you know how to do a binomial expansion, what you end up with is, I'm going to do binomial expansion. So we've got 2m cubed plus 3, that's our binomial coefficient, 2m squared. Oh, you know what, I'm going to put the 1 in as well, plus 3 2m, and we've got 1 squared, plus, squeeze it in on the end here, 1 cubed. So what we've got there is, that's 8m cubed, 2m squared, that's 4m squared times by the 3, so that's going to be plus 12m squared, times by the 1, so that's not doing anything. Here we've got 3 times 2m, so that's plus 6m plus 1. Now, and then we've also got the 2 being added on the end. So what I'm going to do now is just do a little bit of rearranging of I'm just going to look at these terms here to begin with. And I'm going to take out a factor of 2. So that's going to give me 2 lots of 4m cubed plus 6m squared plus 3m. That's that bit. And then we've got these bits here, so plus 3. Now, what we've got is this whole expression now is in the same format as that, because what you've got here, there's your 2 times that bit, so that bit has got to be even. We can then add on 3, which is odd. Even plus an odd is, let's put it there, even plus odd is odd. That handwriting. And so therefore, if we've got an even plus an odd being an odd number, so that's not divisible by 8. So therefore, that's that bit sorted. My odd numbers cubed plus 2, not divisible by 8 either. So if it's not divisible by 8 for the even numbers and also for the odd numbers, then that's all of them done. And there you go. That's your proof sorted.